Hey folks, Matthew Lanigan here with BayWa. We're just going to give it another minute or two. We're seeing people still signing in, so we'll be with you here very shortly. Thanks. Hey folks, I think we'll get started here now. Once again, Matthew Lanigan here with BayWa RE. I'm the Chief Commercial Officer with BayWa. Really appreciate y'all taking some time today to spend with us and the folks from APsystems. A couple of housekeeping notes. There is a chat box down to the bottom right, so please put your questions in. We'll do the best we can to answer them in real time. Otherwise, there'll be breaks where we'll answer them, and anything that doesn't get answered during the presentation, we'll definitely answer at the end. This will be recorded, so for future reference, and we will share it during our next newsletter mail out. Once again, thank you all for attending. I would like to introduce Chris Barrett with APsystems. I've been working with Chris for some 7 years now in APS. It's been a great relationship. They've been a fantastic partner for us. And without further ado, I'll pass it over to Chris.
Well, thank you, Matt. Thank you very much for the introduction. And thank you, everyone, again, for joining today. I know it's a busy time right now for installations, but taking an hour right now just to learn a little bit more about APsystems products and services. We do appreciate your time. So let's get into it. As Matthew said, my name is Chris Barrett, Senior Director of Training for APsystems. I'm located in Austin, Texas. I'm also joined today by Derek Gertz. He is actually your technical support representative for Canada. And Derek is calling in today from Phoenix, Arizona, scattered throughout the country. As Matthew said, there's a few housekeeping things as well. Going to be a little bit of repeat here, but chat box for questions. Please feel free to ask any question you want. We'd love to be able to answer them live. As I said, and that's a lot of times Matthew will kind of jump in and ask the questions, or Derek as well. But like I said, some questions are better answered at the end, and we will do that as well. A copy of the presentation will be provided per the newsletter, along with the recording as well. To kind of dig in a little bit, this is kind of the agenda for today. I know we have an hour, so I want to make sure I covered a lot of information in that short period of time. But nonetheless, just a little bit of introduction about APsystems, who we are and what we are. A little bit about the product overviews, and a little surprise for you here, a little benefit at the end here. We're going to talk about the ECU-C and ECU-R. These two are our gateways, the communication devices. The ECU-APP. This is a way that we're going to interface with the ECU-C and ECU-R. And then also the EMA and EMA app live demo. I'm going to be able to show you or demonstrate to you the homeowner view, what the homeowner or site or owner sees, as well as the installer view as well. far as APsystems is concerned, APsystems is a global provider of microinverters, power conversion equipment. We were founded in California in 2010, so we've just celebrated our 11-year anniversary. Pretty exciting. And 4 major global business units. We're US based in Seattle. We also have a European base in Paris, Asian base in Shanghai, and also a LATAM for Mexico and all of South America in Mexico City. We have additional offices, sales and support offices throughout the world, but nonetheless, these are the 4 major units. A couple key facts. I just want to make sure it's clear. Number 2 solar manufacturer, solar microinverter provider in the world, according to GTM research. And number 1 multi-module microinverter supplier in the world. Currently have over 1 gigawatt installed, and that equals somewhere in the lines of 2 million microinverters. Serving more than 120 countries at this point, more than 100,000 residential and commercial solar sites. And we also are on some kind of third-party financing like Mosaic, SunGage, Dividend, Y-Green, and now LoanPal. The APsystems solution is basically a 3-legged solution. I like to call it that because really it's what I like to call simple solar. It's a grid-tied dual or quad microinverter, which is this piece here. Get this up here. We also have the ECU-R and ECU-C for communication, and the EMA online for monitoring. The second part of the business is the commercial business. So in the commercial business, we're actually using the same gateways, as you see here. We're using the same online portal, but we're actually using a different microinverter, this being the YC1000, a true 3-phase commercial solution. Let's take into the product overview now. As we talked about, the available microinverter designs today are what's called the YC600, and it is a dual module inverter. Think of this as 2 inverters in a single package. Basically, it's going to serve 2 different solar modules. The QS1 and QS1A will have 4 inverters in a single package. So basically serving 4 different modules. And the YC1000, the commercial offering, is what we call a single MPP, single input microstring, serving 4 modules for commercial environment. A little bit of detail about the single phase inverters. So the YC600, as we talked about, is a single unit, connects up to 2 solar modules, independent MPPTs. What's nice about this is each channel is independent of each other. We have 1 channel here and a 2nd channel here. The MPPT range, this is the, if you will, 22 to 48 volts. This is coming off the solar module, and this is where you're going to get the best bang for your buck. As far as module compatibility, 60 and 72 cell module compatibility, but with the new split phase modules, we're also looking at 120 and 144 cell module compatibility as well. One thing that's really nice, and I really like this feature as well, the ability to work in the 240 volt split phase traditional residential environment, but we're also able to use this product in a 240 Delta, a 240 Delta high leg, or a 208Y. With this ability, you're able to work in 4 different power configurations with a single SKU, a single inverter. So residential or commercial for this particular product. Another key piece is Zigbee Communication. This is the communication protocol that we utilize to talk to the inverters on the roof from the gateway. And we'll go deeper into that as we get deeper into the presentation. And for a maximum power output of 600 watts, 600 AC watts. This right here is 300 watts per channel. Like I said, this is 2 inverters in 1 package. And if you only utilize 1 channel, you're going to get 300 watts. You use both channels, you get the potential of 600 watts AC out. With the QS1, very similar, but again, this is now 4 inverters in a single package. All of that same independent MPPT, the same MPPT range, same module compatibility, same power configuration, same convenient Zigbee communication for a maximum output of 1200 watts. And again, just make sure it's clear, it's 300 watts per channel, adding up to that 1200 AC out. In Canada, you guys are very lucky because you actually have a different model called the QS1A. This has increased the power output from the normal 1200 watts to the 1500 watts, equaling 375 watts per channel output. So it's kind of the QS1 on steroids, if you will. Still enjoys that same MPPT, individual MPPT, but what's nice about this is you're actually now able to put larger wattage modules on this device without the risk of any kinds of clipping. Same Zigbee communication, so the exact same protocol, the exact same equipment to talk to, the units. That has the UL 1741, IEEE 1547 compliance. It does include, and it has from the start, 690.12 rapid shutdown compliance. So if there is any kind of issue on the site, removal of AC will have this unit shut down in 1/10 of a second. NEMA 6 enclosure. This right here is basically watertight, waterproof, and can operate underwater for an hour at 1 meter, and carries a 25-year warranty. A little bit about three-phase inverters. So this is right here a three-phase microinverter. This is called the YC1000. Again, it's a single unit, connects up to 4 units, four different modules. You see the 4 different inputs down below. But it is a single MPPT. I like to call that the microstring. So basically, you're going to have 4 discrete inputs, but inside the power is going to be processed under a single MPPT. And the reason that we did that is because it's a commercial environment. And in most commercial environments, we'll have all the modules on the plane, the same exact plane, the same exact orientation, with minimal or zero shading. Again, this is just an opportunity in a commercial environment to utilize this single MPPT. By utilizing the single MPPT, we're also able to utilize different channels and put different configurations of modules. So for example, if let's say you want to use 4 modules, you could use, let's say, 4 300 watt modules, or you could use 3 400 watt modules and just cap off one of the ports and not use it. So what you want to do is maximize the input so you can maximize the output, which is 1130 watts AC output. As we see here, the same MPPT range, 22 to 48, again, is the sweet spot for APsystems. This particular product is used for the 208 and 480Y configurations. And I know in Canada, 208 is prevalent, 480 is not. We do not have a 600 volt YC1000 yet to date, but you never know, that might change. What's nice about this, again, 5-wire system. We're looking at line 1, 2, 3, neutral, and ground, equaling that Y configuration. And the most important part of this, of course, is the phase monitoring and phase balance built into the device itself. That is the key piece right here, because what I love about this product is it takes a residential installer and turns them into a commercial installer overnight. It's just a plug and play solution of the same thing they've been doing on a residential roof. This is now just a commercial solution. What's also nice is it utilizes the exact same Zigbee communication. So once you learn all of our products, residential products, you know the commercial products as well. Same protocol, same everything, super easy. Told you there was going to be a bit of a treat in this presentation as well. So I just want to kind of introduce some of the stuff that's coming down the pipe for APsystems. And this is pretty exciting stuff because we haven't had a new product released in about 3 years right now. But this product right here, the next 2 products I'm going to talk about, it's going to be kind of exciting because what we're doing, we're actually changing the design a bit, and we're creating a situation where we're going to accommodate much larger modules. We're looking right here, we're looking at the DS3 up to 960 volt amps or watts output. So equaling 480 volt amps per channel of output. So those of you that are using larger modules, want to use larger modules, but you're concerned about clipping, those days are gone here very soon. We're going to have 2 different versions of this particular product as well. We're calling it the DS3, which is, like I said, the 960 volt amp or 480 watts per channel. We're also going to have what's called the DS3-L. and L is for lower voltage, right? So this is actually interesting. We're going to go to 730 volt amps for 365 volt amps per channel. These are for the situations where, let's say, you are still utilizing the smaller modules, and you don't want to be in a situation where you can only have 2 or 3 on a string. Right now, we're enjoying 7 on a string. We'll make sure that we kind of continue that, but with the higher output, that's actually going to reduce the number that is on a string. So by having the 2 different versions, if you have larger modules that can accommodate this, boom, you've got your solution. If you're still using the 300s, 60s, 380s, 390s, the DS3-L is your choice. This availability in early Q4, as I'm told. Next part that I want to just briefly talk about is the QT2. This right here is your 3-phase product. This is your true 3-phase built, developed, and made for this environment. Again, designed to accommodate the larger modules. Larger modules are getting bigger and bigger every year. So we want to make sure we keep up with that as well. The QT2, as is designed today, is 2,000 volt amps output. So 500 volt amps per channel. In this picture, unfortunately, I didn't have a good picture here. This is actually the same picture as the previous. This would actually be a 4-port device. We're going to a 3-wire cable. So there's going to be basically 3 lines of power in here. Grounding, double insulated inside of here, and no neutral. So that changes the game quite a bit because now we're going from a Y configuration to a Y and delta. Available in early Q1 2022. Okay, we talked about inverters. Let's talk a little bit about the gateways or the monitoring, how this all works and what it's all about. We have 2 different versions of the monitoring devices themselves today, the ECU-R and the ECU-C. When originally designed, the ECU-R was designed to be a residential product. The ECU-C was designed to be a commercial product. But we're finding is that I would say 95% of our customers are using the R, both in commercial and residential. It's actually, you just need basic monitoring, as it says right here. The ECU-R does the job, does it well. It's very easy to set up using the online apps and compatible with all of our products, including 600, QS1, QS1A, 1000, and any future product that comes out, because we will be utilizing that Zigbee communication, which is key. The ECU-C, as it says here, is an advanced monitoring gateway. And we'll talk more about that as we get deeper. But as you see here, this is a hardwired device right here. This is a commercial device that gets put into a NEMA 3R enclosure or better, outside, adjacent to the main service panel, adjacent to the solar coming off the roof. You can actually see here where we actually can add in CTs for monitoring both production and consumption. So there's a lot more going on here. So if you don't need all of those bells and whistles, the ECU-R is your selection, your choice.
Rob,
We just talked about this a moment, but
sorry,
talk about
Chris.
Yes, sir.
Sorry, just a quick question.
Yes,
before you move on. We're being asked, why is the QS1A only available in Canada and not the US?
It's a great question. I'm jealous. It's only available in Canada because they actually wanted to introduce it in a market like Canada because of the larger wattage modules that are being utilized up in Canada. So that's the answer.
Okay, and
we're not seeing the size of module. Go ahead.
Okay, sorry. One more. On the YC1000, can you mix module types, i.e. 2 360 watt modules and 2 425 watt modules?
On the 1000.
Yes.
I would say no. I don't like to mix it on the 1000. I like to kind of keep the same voltages coming off.
Great, thank you.
So the answer is, could you do it? Probably. It's probably not best practice. Maybe the better answer.
Okay, great.
All right. And people always ask, well, one thing that's interesting in this industry is a communication protocol, and that's one of the things that we always talk about, and reliability of modules, reliability of inverters, and we rarely talk about reliability of the communication, both to the inverters and into the internet. So what APsystems has done is we've changed the communication protocol from our inverters to the gateway. In the past, and some of our competitors continue to use, is what's called PLC communication. PLC communication is basically running over the power line. So the gateway is plugged into an outlet somewhere in your home or business, and that then communicates on the power lines all the way to the roof. So sometimes that can be a tortuous path. Sometimes there could be noise on lines. And as we're trying to show with the slide, NEC 2010-12, this is when they introduced their arc fault protection. In 2014, we introduced arc fault protection in all bedrooms. And where do people put their offices, where all these gateways are sitting, or their internet? In an extra bedroom that is now protected by an arc fault breaker. Trying to pass a PLC signal through an arc fault breaker is impossible. And unfortunately, way back in the beginning when this first came out, we had a lot of fault strips on the arc fault breakers. So what APsystems decided to do was really kind of change the game a little bit and say, let's use Zigbee communication, because Zigbee communication, we're avoiding arc fault breakers altogether by traveling through the air. We're using this protocol to avoid these arc fault breakers, the arc fault trips, and provide good, reliable communication. Because with Zigbee, we're actually, instead of serial communication, we're doing this kind of dynamic communication. It's a peer-to-peer or point-to-peer. And we'll talk about that in here in a second. With the Zigbee communication, this is really the big difference here. Power line is narrowband speeds. It's a serial point-to-point. The device asks a question, it pushes an answer. With Zigbee, it's a broadband speed. Zigbee is very much similar to a Wi-Fi connection in that regard. Like I said, go-to wireless protocol because of the self-healing nature of it. It is a peer-to-peer communication as well as a peer-to-point. And I'll show that in the next slide here. I like to use this slide because it generally just kind of makes it really clear as far as what's going on. So Wi-Fi that we use in our homes and businesses. Think of the black dot here as your router in your home or business. So this is your computer. Your computer talks directly to the router. Your Xbox talks to the router. Your phone talks to the router. You know, all your devices, all your peripherals in the house, peers, all talk directly to the router. And that's the only path that they can do. With Zigbee communication, it's slightly different, but very similar. You see right here, IEEE 802.11 is what we use in our home businesses. That's what we call Wi-Fi. 802.15.4 is called Zigbee. And this Zigbee here, like I said, it's in the same family. It's very, very similar. And what it means is it communicates over the 2.4 gigahertz band. It has the same distance requirements, so basically 100 meters from the theoretical max from the gateway to the inverter. And what it also adds is this peer-to-peer communication. As you see on the Wi-Fi side, the peer being the phone or device, to the point being the router. Fast forward over here to the Zigbee side, we're looking at the gateway or the ECU here being the point, and the peer being the inverter. All these little white dots here are the inverters. What's nice about this is, let's say, for example, I'm trying to talk to Matt on the phone call. I know he's on the phone. I can see his name on the list, but he can't hear me. So I'll talk to Derek, and I'll say, Derek, can you ask Matt this question? Derek will then ask Matt the question. Matt will then respond back to Derek, and Derek will respond back to me. I still get my answer, but I may not be able to talk to Matt directly for whatever reason. Maybe there's some obstruction. Maybe there's something going on that roof, but it's a self-healing mesh network. So I'm still able to get my answers, even if I can't directly talk to that inverter. Then other inverters can talk to each other and pass messages through them. This particular protocol here has literally saved hundreds and hundreds of hours of talk time on tech support phone calls, and really, most importantly, reduced truck rolls for you guys. So the ECU-R itself, like I said, is the R version here, the simplified version. Super simple. Two different lights on it. On the first light right here indicates that you've got power to the device and that it is booted up and the Zigbee chip is communicating. The second light here is the COM light. And the COM light indicates that you now have internet connection, excuse me, and you have communication to our servers. So you're able to push data back and forth. The back side of the device, very simple again, the Zigbee antenna right here. One of these is the antenna. We also have a Wi-Fi antenna as well. But more importantly is, again, RJ45 Ethernet port. The reason I highlight that is a lot of us in the world, we use Wi-Fi for everything. I use it a lot, but there's nothing better than a hardwired connection, because of reliability. Again, goes back to that conversation we had about communicating to the inverters. Now we're talking about communicating to the internet. And I would argue that the communication to the internet is equally as important as a reliable inverter, as a reliable module. Because I can guarantee you, and many of you on the call today have rolled trucks to go out and fix Wi-Fi connections. Nothing wrong with the solar system at all, but you get an angry call from a customer that says, my system's down, it's not working, you need to fix it. And it's simply a Wi-Fi connection. APsystems supplies you with an Ethernet cord in the box. I highly encourage you to use it. Again, I'm just trying to reduce truck rolls. And I said, with the advent of the Zigbee communication to the roof and the hard line to the backside of the router, we have literally reduced our phone call volume by 50%. And I'm sorry, and that's just paying it forward to you guys as well. So you'll reduce your truck rolls and your phone calls with happy customers.
Yeah, and I have a quick tidbit there, Chris.
Sure thing.
On that previous slide. So with that cloud light, there is a couple indicators that you can know of what's going on with the internet connection, just for your knowledge. If you ever look at that cloud light and it's solid green, that means you have a valid internet connection and the ECU is connected to our server. If you ever see that cloud light blinking green, that means that there is an internet connection, but it's not connected to our server. And if the cloud light is blank, that means there's no internet connection and it's also not connected to our server. So if you ever are setting these ECUs up and see that cloud light blinking green, that means that it is attempting to connect to our server, and give it a little bit of time and that should go solid.
Great, thanks for the addition. As far as the ECU is concerned, as I mentioned before, the power interface is a hardwired connection here. Everything on this device says commercial, says industrial. It has the same exact Zigbee communication protocol, but again, like I said, you're actually hardwiring this device. This is nothing that you'd be putting on someone's desk, hanging on their wall in their office. This is definitely a commercial product. As far as the CTs are concerned, production CTs, consumption CTs, relay interfaces, inputs, outputs, all kinds of communication protocols, RS-232, RS-45, and most importantly, this network interface. Again, I can't say enough about the hardwired connection. This device also has the same LED lights though, so as far as power up, as far as communication, and this one actually adds an additional light if there's any kind of fault on the system as well. As we discussed, ECU placement is key. You obviously want to make sure that the ECU is placed somewhere within, of course, line of sight is always the best. In most residential environments, you're probably, 10 meters away. So it's less than that. And through traditional construction methods, you won't have any issues whatsoever. Just remember that if you can walk away from the Wi-Fi, how far away can you walk from the Wi-Fi to before you lose signal? The same thing with Zigbee. So about 100 meters line of sight, of course, with any obstructions, we're talking drywall, steel, concrete, whatever is in their home or business, that number will reduce. So the closer you can get to the array physically is always the best. We also do have, and you can just buy separately from BayWa, is the extension antennas. Let's say you need to have the ECU in the home, but you had to run a cable outside for the antenna. That's also available. The ECU app, which we'll talk about here shortly, is really your key to success. Once we get into the app, you'll see why this has been such an incredible tool for us. We're kind of trying to redefine how to set up a solar system for the installers. Try to simplify the process and kind of front load it with information so you know what's going on that roof at any given time during the installation, not just at the end. And most importantly, like I said, is to verify that communication. Make sure before you leave a site that day of installation, you're going to know that you've made good DC connections, you've made good AC connections, and you're producing power. It's critical. Like I said, the last thing I want to do is make you roll a truck to fix a problem that you could have fixed today. Let's say you missed a DC connection and you go back and you set up the EMA account later on, and 2 days later, 3 days later, you find out that, oh, I must have missed a DC connection. You have to roll a truck to go fix that. But you could have known that the day of installation. So, like I said, this just highlights it again. ECU-R, as far as this setup is concerned, it's a simple plug into the wall socket. or a power strip or whatever you'd like. And no longer do I need good, clean PLC communication because it's not required. Everything's going through the air. Connection today, Ethernet or Wi-Fi. And we're about to announce also cellular connection as well. So you may have one of those sites, either for security reasons or the customer just doesn't have internet. That will be soon available here, probably sometime beginning of Q4 to the router and then to the internet. As I said, the ECU-C, because it is an industrial product, it gets direct wired into the panel. But you get to enjoy that same Ethernet or Wi-Fi, again, with cellular connectivity coming by Q4.
There's a couple of quick questions.
Hardwire connections. Sure.
Regarding the Zigbee protocol, how does the townhouse situation work where there be multiple arrays with multiple ECU-Rs? Would peer-to-peer communication happen only between microinverters within one system, or would the micros across different systems all communicate together?
They would only talk to each other. There's when you're scanning in the serial numbers using the ECUAPP, you're basically making a marriage between the serial numbers that are in that system. So they will ignore anything else. They might hear noise in the background, but they won't have any communication. They won't jump on each other's networks.
Okay.
So you're creating a closed network.
And follow up to that, for the ECU-C, do you need to hardwire in production CTs, or do they communicate with the microinverters via Zigbee?
CTs. So there's actually two things with the ECU-C. So the ECU-C will have the traditional measurement of power production per module. So you'll get that through the Zigbee communication. The CTs are only for aggregate production and consumption numbers. And what we're doing with the aggregate production and consumption, let me actually go to that next slide here. You can actually see, we're actually monitoring consumption of the building, and we're monitoring the production of the roof. And this gives us the ability to use the advanced functions that are inside of the ECU-C, something like what we call a zero export function. For example, if let's say the building that this is installed on is consuming more than the array can produce, the array will be allowed to run at full capacity and push as much power as possible. But if the building or the home is not drawing as much power as the array is capable of producing, then the array will actually start shutting down module by module by module to meet the consumption of the home and not export anything back onto the grid. For your use in Canada, the only applicable use for the ECU-C is a 3-phase commercial environment. This does not operate in a split phase, 240 volt system. So just make sure that's super clear. This is definitely a commercial product when using the advanced functions. Did that help answer the question?
Yes, thank you. And does APS have rope CTs for larger commercial service entrance cabalas?
We do not. So we do not have any Rogowski coils at all, no. So we basically have a split core. I have a picture of one. Nope, I don't. Split core, but so for the production side, up to 80 amps for production. On the consumption side is 200 amp service. This right here, does that help answer the question?
Yes, thank you.
Excellent. All right, let's just give you a quick wiring diagram here for a 3-phase system. Again, production and consumption. One question that we do get asked, and I'll answer it right now, is this a revenue grade product? And the answer is, interestingly, no. It's revenue grade accurate. It just does not carry the ANSI C12.20 stamp of approval. So on the consumption side, we are 2.5% accurate. On the production side, we are 0.5% accurate. So like I said, if you want aggregate power production numbers and aggregate consumption numbers and be able to see that in the online portal, this is a great product for that. But it definitely is not utilized or cannot be utilized for any kind of revenue grade situations because we just do not have that stamp currently. It just gives you an example of what it looks like, some of the graphs that you'd get on the online portal. So you'd see the consumption, you'd see the usage, and you'd see the production from the PV. All right, internet connectivity. Again, I just want to make sure this is super clear. And like I said, this is obviously your choice. But at the end of the day, we always talk about reliability. And I think having a direct wired Ethernet connection is just a really, really smart choice. And like I said, I really want to try to reduce the number of truck rolls that you guys are making to connect internet. And with the ECU-C, I'm sorry, ECU-R, we make it super easy for you to be able to plug that device in, nice enough that it can sit on someone's desk or hang on their wall. I have a lot of installers that actually are taking Velcro and sticking it to the side of the router. It's just that easy. And with the supplied Ethernet cord, you just save yourself a truck roll. That's really, really an important piece of the puzzle. Again, Ethernet cable is king and reliable and secure as well. That's the other thing we don't talk about as well. So through the air, it works just fine, but boy, wouldn't it, nothing better than an Ethernet cable to the router. Wireless router does the trick again, but like I said, I'm sure a lot of you have gotten home and things aren't working properly. You reboot the router or you reboot the device, and everything just comes back. Again, this is more of a truck roll prevention. We're not saying you don't do it via Wi-Fi, and it works just fine. I just want to make sure that you've got a super reliable connection and that you're not maintaining internet connectivity for a solar system, for solar installers, not Ethernet or networking people. Okay. So let's dig into the ECU configuration. This is the ECUAPP section. This is actually the best tool in your toolbox. This is really nice. So what we do right now is we've actually got a situation where we're actually doing the scanning of the serial numbers into the gateway. So the ECUAPP, as it says here, allows you to scan those serial numbers. Scanning is the key thing. I don't want any installers out there typing anything in or going through what was called an auto detect. In the old days, the old days was 3 years ago. We had a situation, we had it, our competitors have it, where you hit a button and it starts to go out and look for all the inverters that you've just installed on the roof. And this sounds really cool. And like I said, we've done it ourselves. But let's say you've installed 10 inverters and you find 9. You got to go figure out which one you can't find now, what's going on, where's the problem. Or even worse, let's say that you put in 10 inverters and you find 20 because you've actually found the neighbor's inverter as well. Because through PLC, it doesn't care. Like that example you just asked a few minutes ago about the Zigbee, I'm locking these serial numbers into this ECU. That ECU is only going to talk to inverter number 1, inverter 2, and inverter number 3. That's on their system. That's all they want to talk to. That's all they'll communicate through. So we're going to make sure that we lock those in and create its own secure network. So that's really critical. Now, the other thing that's important to recognize with this new method, we're actually able to preload. So any of those you folks out there that actually kit your jobs, get everything ready the day before, and have it ready to go to Mrs. Smith's house the next day, you can actually turn on the ECU-R. You can scan the serial numbers that you're going to be putting on the roof the next day, load them into the ECU, unplug it, and put it back in the box. When the guys get to the site to install the system, at that point, the first thing they do when they get to the site is turn on that ECU. Before you even put the rails in, before you even put the first inverter in. Because what's nice about the Zigbee communication, you're going to start building your Zigbee network as you build out your roof. And throughout the day, you're going to be able to see progress and also see problems. We'll get into that. With the ECUAPP, like I said, it's I say this right here, the power in the palm of your hand, and that is no joke because you're able to actually see power production. You're actually able to see the DC connections, the AC connections, and power production before you even leave that day. And one of the things I always mention too, a lot to the business owners out there, this is a report card. This is a report card for your installers. When installers are done doing their business that day, they can send these 2 screenshots back. These 2 screenshots indicate to you all the inverters have been installed on the roof. All of them are green. All of them are actually producing power. Everything is good on the site. And then down here, this also shows you the number of inverters. This will say 1 of 2, 2 of 2. Let's say you installed 10 inverters that day. The numerator is the number of inverters talking. The denominator is the number that's expecting. So at the end of the day, the screenshot that you want to see is I've installed 10 inverters and 10 inverters are talking. That's the critical thing. And the second screenshot is this, basically this report card, reporting time of all your modules green and producing power. Again, the last thing I want to do is you to find out at the end of the day that you've got a problem. You'll be able to find the problem at 10 o'clock in the morning, because everyone on your crew can have this app on their phones. They can check progress and they can say, hey, Joe, looks like you missed a connection on that module over there. Oh, yeah, click, click. Boom, 5 minutes later, it will start communicating. The nice thing about Zigbee Communication, I don't even need AC on the site for that day. I mean, if you have, cool, that's great. But the DC from the panel, the first connection, it doesn't matter what channel you plug into, 1, 2, 3, or 4, or 1 or 2 on the 600, it will turn on that Zigbee chip and start communicating, start chirping. And as you're building your array, you're building your Zigbee network. The tool itself can be located on our website. You can download directly on our website, or most people would just go to the Google Store or the Apple Store to download this particular tool. Type in APsystems, type in ECUAPP, whatever you'd like, you'll find it there. As far as the serial numbers are concerned, the ECU IDs and versions right here, every single product that we sell, both inverters and ECUs or gateways, all have 12-digit numbers. All of them, which like on the ECU-C here, it's located on the face of the device. The ECU-R, it's located on the back. If 215 means you have an ECU-C. If it starts with 216, means you have an ECU-R. Same thing with the microinverters. 12-digit serial numbers located on the labels. On the inverters themselves, there's actually 5 different locations we have the serial number. So on the face of the unit, we have 2 which are peelable, and these right here are used primarily, we can use them for scanning, but they're primarily used for making the module maps. Third one is here permanently on the device. The fourth one is on the side of the device, and the fifth one is actually in the box itself. In the box, we're actually able to see all the serial numbers and scan the serial numbers from the sealed box. I'm going to kind of go through these. We're pushing up on time here, so I want to make sure we get to the live demo as well. But let's go through quickly. Downloading the app, we all know where that is on the store. Find it, download it. All this is doing is you're taking this app and you're creating a connection from your phone, a wireless connection from your phone to the ECU, either the ECU-C or ECU-R. So to do that, you're going to basically go into your phone settings and look for this SSID or this name of the device. You connect to that device. You're going to put in the password, which is 88. That's the same on both the ECU-C and ECU-R, and then hit connect. Now you're going to see that on your phone that this ECU, you are not connected to this device, but there's no internet, and that is true because you're not connecting to the internet. You're just connecting to a hotspot. You're making that wireless connection between the 2 devices. When you open up the app, you're going to see here ECU Connect. This green dot is going to indicate that you now have a good, solid wireless connection between your phone and the ECU. First thing you're going to do is come down to Settings. Under Settings, first thing you want to do, date and time. Just make sure that's set up properly. And I always recommend using Sync Phone Time. When you sync phone time, you're going to have the phone time and the calendar all set, ready to rock. Done. Next part is ID management. This is where you're going to go in and you're going to start scanning those serial numbers. Under ID management, you see the scan function here. Scan function is going to open up a scanning feature on your phone. It's going to scan the barcodes. Once you scan those barcodes, you're going to start locating them down just below the scanning window. In this particular example, we scanned in 2 serial numbers. We said in these 2 right here, and these are the 2 serial numbers. One thing I want to point out is you see the font color is black. Black indicates that the serial numbers have been scanned into the ECU app, but have not been pushed down to the ECU. This is where this function here comes in called sync. Under sync, I'm going to sync this, and they say, are you sure? Are you okay? I said, yes. Once I sync them, notice here, they turn orange. Orange indicates to you and to me that the serial numbers have been scanned and then pushed down to the ECU successfully. Next function, and many of you will never need to use this. This is more of a function if it's used in, let's say, for California. California requires a special grid configuration. This is where installers would come in and actually, because usually it's shipped in 1741 240 mode for US and Canada. But for California, this is where they would come in. They would select USA Rule 21. And from there, you say select, you say update, and boom. At 5 minutes later, it will go into what's called Rule 21 mode. I was talking about before, here, 2 of 2, 10 of 10, 20 of 20, whatever number of modules are on the roof, or inverters are on the roof, this is the number of inverters that are talking and the number of inverters that have been installed. You want these to be the same at the end of your installation because that's your recipe for success. Knowing that you've got 10 inverters on the roof and 10 of them are talking. Another feature we provide is inverter signal level. This right here will actually give you the ability to see how strong of a signal. So let's say you're questioning, like, is it communicating or not? This is very much like a cell phone bar chart like we have typically. Like it says right here, 5 bars are always great, but 1 bar is all you need. So don't want to, if you see only 1 bar, don't think it's a problem. As long as we got good communication, that's good. But if you see 0 bars, obviously, that's why you've got an issue with communication. But we give you the ability to see how strong that signal actually is. The next page here is the data page. This just gives you that where you get that screenshot I was mentioning. This right here, we're actually able to see power production. You know, when you first put a system in and it's not communicating, you're going to see modules that are gray, indicating to you that these serial numbers are in the ECU, but they're not communicating to anything. As soon as they start talking and communicating, they'll turn green with no numbers. As soon as you apply AC and wait 5 minutes, then you're going to see green with numbers indicating the number of watts that each one of those channels is producing. LAN features and WAN features. I'll kind of run through these, but this right here is a LAN feature. It gives you the ability to go in and see if the router has given an IP address to the device. Conversely, some of you out there may be putting installations in at banks or any kind of high security places or high-end homes that require a static IP address. Basically slide this radio button open here and we'll open up a whole new set of things down here where you're going to actually able to type in the static IP address for that customer. Same thing under WLAN. Should you choose to use the wireless function on this device, you click on Wi-Fi or WLAN. You'd look for the available Wi-Fi that you want to connect to. You type in the customer's password and hit OK. And now that ECU or that gateway is connected to that router. Again, you're absolutely welcome to use the Wi-Fi. I highly recommend using the Ethernet just from a reliability perspective. ECU-C functions here. This is more of the advanced functions we talked about. Some of the metering functions that can all be changed and easily fixed in the EMA platform. Communication, as Derek was mentioning, the lights on here, power and communication, and now with the blinking feature, that actually adds an additional element for troubleshooting. Same thing with the ECU-C. And when you're all done, what we want to do at this point is basically using the EMA, or the online portal, which we're going to demonstrate here in a moment, is setting up the homeowner or system owner's account. You're going to connect that account with your installer account. You're going to finalize the array configuration. This is where you're going to go and do all the mapping. And then from there, you're going to be able to provide your user with their credentials or their username and password. One thing I also want to introduce on this call as well is what's called the EMA Manager. This is a new addition to the fleet of online apps that we currently have. This is an installer-specific application where we've actually changed the game a little bit more, giving you more power in the palm of your hand. In the past, if you wanted to look at your flock or your fleet, you'd have to go back to a online portal, your computer, try to log into a website on your phone, which was a little bit arduous. But we've actually gone to a point where now this EMA Manager gives you the ability to do statistical fleet management. You're actually able to see all your fleet, where it's located, how many inverters are out there, how many different kinds. I mean, look at 500s, 600s, QS1s. What do you have deployed in your flock? You can do system health checks. You can actually see it right from the phone again. You can create the accounts now on a mobile phone application as well. And what's so interesting is that same thing we just went through, the ECU app is now fully integrated into the EMA Manager. I encourage all of you to download it. It's currently available on iOS and Android. So please take a look. It's very self-explanatory, just like most apps. It gives you a lot more power in the palm of your hand as an installer. Okay, hold on one second. Let me pull up the EMA real quick here. Okay. Let me log in. So I'm gonna start with a homeowner view. So the homeowners and installers all go to the exact same starting point. You would log in at the same login page, but your login credentials would take you to 2 different locations. Okay, so this right here is the homeowner view. What we tried to do is try to simplify this view completely. So we would try to reduce the number of questions coming to you, the installers, from the home or site owners. We try to present the information in such a way that it's easily digestible. So we're looking at here is the daily production for this particular site, this one site right here. This is one of our test sites located in San Diego. And you can see right here, power production throughout the day. You can also see power production for the week, the last 7 days. You can see how much the system has produced for every day for the last 7 days. And today, obviously, just started. Come down below under monthly energy, you actually see how much the system has produced in a month. So basically, you got this pie graph, which will continue to grow throughout the year. So you'll be able to see every single month as the month is happening. As you can see, June just started, right? 2 days, and it's just a small slice of pie, but that pie-sized pie will grow as the month continues. The next page is the module page. And under the module page, this is where the customers are able to see module by module performance of the system. If you come down here and grab this orange bar, you're actually able to slide back and forth and see the production throughout the day. Same thing you saw before, but now you're looking at it as a module by module. You can also go back in time. Let's say I'm just going back to yesterday, June 1st. What was it like June 1st? Oh, it's beautiful bill. Next thing, come down here and grab the same thing and slide it back and forth. And I can actually see the shading going across the roof throughout the day. I can see from the beginning of the time, from the beginning of the morning until the evening, till the sunset. Quite nice. I also, on the report section, have all the data from the beginning of time. One thing that APsystems does, and I really like this feature a lot as well, we don't truncate any of the data. The data is, we don't truncate a bit of it. As you can see right here, this system was installed back in April of 2015. And here is the monthly data for the entire system through all the years. We're looking at almost nearly 5 years of data here, of complete data. You come up here a bit more, and we do that same data, but we graph it out. So 2015 was an incomplete year, so I'm going to just turn that off, take that out of the equation. So I can click this button here, 2015 disappears. 2021, incomplete. So this is a graphically example of year-to-year performance of this system. So now I'm mapping 2016, 17, 18, 19, and 20. All those years are readily available to us, and we can see graphically year by year what's going on. If you come up here, you can actually, this is a great chart. Like 2015 we know is incomplete, 2020 is incomplete, but look at 2016 to 2020, and you can see module degradation over the period of time here. So we're looking at complete years, and of course there's other things, factors, weather, things like that, but clear that over time modules degrade, and here it is a perfect example of that happening throughout the years. And of course with all the environmental benefits. Okay, let me log out of this, and we're going to log into an installer account and give you an idea what an installer account looks like. Same thing. So we log into the same exact website, go to the same exact location, but now we're being taken to a new location because I'm logging in as an installer as opposed to a site owner. As you can see here, close this out. As you see here, this is the customer account. So if this was this test site, we had more sites installed, we could see your entire fleet here. You see everything, all your, it would just keep lining up below this line here. Most importantly, this gives you quick information as far as who the site is, where it's located, system size, the installation date, which we know was April of 2015, and more importantly is the system status right here. This right here gives us 4 different statuses. And right here, you see right here, we went through the standard traffic light configuration. Green being good, yellow meaning there's something going on the site that may need some attention, red, there's an issue, typically internet related, and then the gray dot or the black dot is a self-selectable one for you. Basically, there's two different reasons that would show up. Let's say you just installed the system and the system's never reported, it would show up as a gray dot. Or, for example, if you had a customer in the middle of nowhere that never had internet, has no interest in having the internet, you can actually select that gray dot, indicating to you that there's not a problem with the site. It's just that it's a known issue that the customer doesn't have internet and never will have internet. So let's just dig in here. As you see from the installer view, they get the same daily graph up and down here. They also get the same module view. Almost there. So same module view. You can actually see that's going on. And you can go back and forth and the installer can actually see module by module performance. The installer can also get, which the homeowner or site owner does not get, is the detail. So we click on detail here. We're actually able to go in and see detail for every single module on this roof. I can look at this information every 5 minutes throughout this day today, how much this has been produced. I can see DC voltage of every single module, what's going on here, and I can also see the current. And I can do that for either channel A or channel B. I can also look at the AC for the site. So I can see right here, 234 volts, 235 volts. I can also see the frequency and the temperature of the site. As the day goes on, we're already at 30C. We started at 14C. Other nice feature we have built in is the compare function. Under compare, this is where I can compare channel A to channel B on the same exact inverter, or I can look at different inverters on the roof. I can compare one inverter to another inverter. So now I'm looking at inverter 16 and inverter 63, both their channel A's. I can compare all this information. I can do A channel, I can do B channel. I can also come down here and turn off features that I don't, let's say I don't want to look at power. I can reduce or eliminate the power from these. I can only look at what I want to look at. All this information is readily available to the installer, but not to the homeowner. In an interesting time, I'm going to jump down here to registration, just show you some basics about the system and setup. Here it comes. This is where under personal information, this is where you'd be setting up the customer name, where they're located, their addresses, their phone numbers, what kind of system it is, system module size. It gives you just a reference for future. That way you don't have to remember, what did I install at the Nelson house? Oh, I installed the LG 305s. Okay, great. Right. Good information to save. Most importantly on this particular page is permission list. I just want to show this to you. This is where we give you the ability to turn on or turn off the module view for your site owner. Some of you out there have requested not providing that information to the homeowner. We've actually given you now the ability. So full would give you the ability to give them the module view. Simple would just remove that from them. They would remove it from their online portal and also from their EMA app. Under inverter information, this is where we go through the effort and actually add serial numbers. So I come over here and I come down to add. And APsystems has given you the ability to basically suck in and create the marriage of all the serial numbers on the online portal by using this what's called import from ECU. If you've done scanning on the site, left the ECU on site and left it online when you left, all that information is being pushed up to the cloud. By hitting insert UID to temporary list, this would actually populate this over here on the right. All I'd have to do is hit submit and everything is done for me. I don't have to type anything in. I don't have to manually scan anything or cut and paste anything. If you choose to do that, which again, there's really no need to, you can come over here and you can choose what you're installing. You can actually type in or scan or cut and paste the serial numbers here as well. Under group view, this is where you'd actually go through and map the system. I'm going to go over to edit. Go over here to detailed. Say okay. And this is where I'm actually able to go in and edit stuff. I can come over here and actually drag the modules where they really are on the roof. I can also change the orientation. Let's say these are in portrait mode or landscape mode. I can do that and I can hit save. I just want to demonstrate to you how fast this actually happens. If I go back over here to module view, you can see the changes that I just made are now sitting here on the view for that customer in real time. Just as simple as that. Okay. Hey, Matt, I think that's good for here. I think we're pushing up against the 1 hour mark here, so I'm going to be respectful of that.
Great, thanks, Chris. Really appreciate it, and Derek as well. I do have a few follow-up questions, so let me just pull these up here. Where's 1 second? So for the commercial one, looks like there's a consumption feature. Does this eliminate a third-party home energy monitoring system?
It could. It's an aggregate of the consumption of the site. It is displayed in the EMA portal, but it does not have any kind of recognition for appliances and other things like a Nurio would have. It's strictly the aggregate of the consumption and production.
Will an ECU-C work the same on a single-phase residential system?
Yes. It will actually utilize the Zigbee communication, and you'll get the module by module performance. You can actually monitor both lines for production and consumption. You just will not be able to utilize any of the advanced features and functions of the ECU-C.
For the ECU-C, do you need to hardwire in production CTs, or do they communicate with the microinverters via Zigbee?
With the ECU-C, they do both. So if you want to get module by module performance, that all goes through the Zigbee communication. If you want aggregate production and consumption numbers, you would have to wire in CTs onto the production lines and the consumption lines.
So if APS doesn't manufacture larger rated CTs for interconnection to the ECU-C, is it compatible with other marketable CTs?
The answer is yes and no. So the answer is yes, it would work with the larger CTs. Unfortunately, the accuracy would change based on the size of the CT. So that's the only risk you run. So if you're concerned about accuracy, if you just want something that's close, then sure, you can put whatever CT you want it on, even some of those Rogowski coils. But again, it would definitely affect the accuracy, because the coils, these CTs that we sell, are specific size and specific lengths of wire as well. So all those factors would change. And unfortunately, in the ECU today, that may change in the future, but in the ECU today, it's specifically set or tuned to the CTs that we sell.
Okay. Backtracking to the Zigbee topic, will Zigbee cause any type of interference with a client who uses ham radio equipment or vice versa?
I'm not familiar with ham radio. I mean, I understand the term, but as far as frequencies are concerned, so it communicates at 2.4 gigahertz. So I guess whatever rules apply to Wi-Fi in the home or cordless phones, if people still use anymore, that would be the same. I guess that would be something to look up. But Zigbee is exact same protocol, exact same frequency as Wi-Fi. So if Wi-Fi interfered with ham, then I would assume, like I said, I don't know definitively, but with ham, but Wi-Fi has the exact same communication protocols and bursts.
Okay. And last one I saw that split cell 120 or 144 do not work on the inverters at the start of the webinar. I think that's a misconception, obviously.
They don't work with the 120, 144, so you said?
Yeah, so they will
misconception.
work.
No, they absolutely.
If we
The most important
don't,
thing for us is, I said, the most important thing for us is voltage and current. And online, Derek, you can probably provide that information as far as the E-Decider is concerned. We have an online portal. You go to our website, and it would help you determine the module compatibility with any of our products.
That is correct. It's listed under our library, under the resources tab. You can go there and enter quite a bit of information from the module you want to select, and it will let you know if that is compatible with our products and also which products it would be compatible with.
great. I think that's it for now. So we'll wrap. Thank you very much, Chris and Derek. Really appreciate you taking the time to help educate us and our customers. Just to let everybody know, we do have plenty of stock of the APS products in Alberta, BC, Ontario, Nova Scotia warehouses. If you have any follow-up questions, please reach out to your we have recorded this and it will come out in the next newsletter. And thank you all once again. Really appreciate taking the time. Hope you're all taking care of yourselves out there.
Thanks, everyone.